People contact me from all over the country asking the same question. Why did my glass break? Mark, help me. So right away I say, send me a picture, and when they send a picture, it's of varying degrees of quality and clarity. And then I say, well, what would be really great is either if I could see it in person or if you could send me a piece. So today I have that very situation here in Chicago, and the homeowner has graciously allowed me to shoot some footage of what I would do in this situation in real time. And what I'm going to do is to go in and take a look at the fracture of the glass and then extract it for further study under a microscope. I happen to know that this glass is tempered glass because I've already seen pictures. It breaks in 1,000 pieces when it does break. And when we have that situation, many times it stands in place. It's all sort of locked together like a big puzzle, and if you don't disrupt it, it will stay there for a while. So I immediately asked the homeowner to get somebody to get some tape all over the glass to hold it together so it wouldn't come crashing down, and so that I could come by at a later time and extract the sample that I'm looking for. So here we go. Here's the big reveal of the broken glass. We can see right away that this is tempered glass because it is broken in a lot of little pieces. Tempered glass is glass that has been heated and then rapidly cooled to create a very strong internal stress that's permanent within the glass. And that stress is there to create a fracture pattern that's like this. It breaks in very small pieces to make it safer in the event of breakage and human contact. It still isn't that safe, but at least it's safer. When we look at glass breakage, we're always looking for the fracture origin because that's the beginning of the story. And in this case, it's actually pretty easy to see. The origin of the fracture is right here. It's where all of these cracks seem to converge. And that is our fracture origin. So you can see it's like spokes emanating from a central spot. That central spot has some interesting properties. We have what's called a butterfly pattern, or a figure eight, that is here present right at the middle of the fracture origin. That's where our entire story is. This is where the secrets are held about why this glass broke. To make extra sure the glass surrounding the sample is stabilized, I've put some stronger tape right around the area that I'm going to extract. And then to make sure my specimen that I'm extracting stays intact, I put a nice stout piece of tape over that also. I think it's going to come out. Be ready with a few more things, pry bar and a sample bag. Here she goes, and that's it. Now we take it back to the lab and look at it under a microscope. And one last touch to stabilize this until the glazers come to cover up the hole. And there's our perfectly preserved butterfly pattern.